All right, so hello everyone. This talk will be about a didactic measuring node for equilibrium evaluation. So first of all, let me introduce the team. So here is my colleague, Ivan Hernandez. My name is Juan Diego Zambrano, and there's also another member of the team, Abderrahman, who couldn't be here, sadly. But how this project came to life, we want to thank Magenta and Giovanni for their support. Magenta came to Italy and in conjunction with Human Performance Lab, which is a laboratory located in Lecco in Italy. This laboratory dedicates to measure the performance in sports for adults and children. And right now they're implementing some facilities for children, like playgrounds, that needs to be monitored and measured. So this is the agenda that we're going to cover today. First, we'll see the problem, definition, and challenges, the proposed solution, the hardware selection, the Windows format that we have development, and some future developments that we are thinking to implement in future versions. So let me introduce my colleague. He's going to show you the first thing.
So first of all, we started to try to find a target population in order to address the problem of making useful our device, making the most impact possible. So we started searching for that kind of population, and we found that the children are particularly interesting population because some in their early ages, it's really important to develop their skills and their motor skills, especially for one that have some physical or developmental challenges. And this kind of tasks also requires that are repetitive and structured, that for a child is usually boring to do repetitive things. So we wanted to make it more interactive and more useful for the therapists and for the doctors. So the main challenges we found was like in the traditional therapy, there is a lack of engagement for the children and for the user because they are so repetitive, and we wanted to solve that. Also, there is not a real-time feedback for the user, and the data that they acquire often is lost in the time. And we wanted also to increase the motivation of the user. So we started to search some type of solution that other authors have studied in the past, and we found that particularly the game-based therapy is a really interesting way to solve these problems. So the author says that this type of therapy is as good as the traditional one, but give you more engagement for the little ones and give you another way in order to develop those tasks. So for that, we propose this solution that is a wearable device that you wear in the chest. It's a really minimalistic device that is really handy and easy to use. As we can see, there is not too many parts on it. And we wanted to make it useful for the therapist and easy to use. So this is more in detail the device. It consists in a 3D printed case and a PCB that is really simple and is powered by 4 batteries. So for development, we have to select some hardware in order to address all the challenges that a device of this have to handle, like measuring the movements in a precise way and with a certain accuracy that is required. So we started finding in the market what type of MCUs are available around there. There is many types, but we found particularly interesting this one that is development board developed by Arduino powered by the Nordic NRF 52840 MCU. That's a ultra low power consumption MCU, and is capable of communicating data through the protocol Bluetooth Low Energy. That, if you haven't heard about it, is a really good protocol to transmit data in an efficient way and really robust. And the other thing that make us to choose this device is that already have an integrated IMU. That with that we can record the movements and filter the data in order to transmit it to a central device that will process and make it useful for the therapist. More about the integrated IMU is a really high precision IMU, and it is composed by 3-axis accelerometer and 3-axis gyroscope. And it's also interesting, this one, because the power consumption of it is around the microamperes range. And also it's very robust. It's industrial grade one, and it gives us like the accuracy that is required in this kind of field. Finally, we propose 3 different mechanisms to give feedback to the user. One is a haptic one that is composed by the vibration motor that will help us to transmit a haptic response when the user is doing good the exercise or is going in a wrong way the exercise. Also, we wanted to make it simple and easy to understand with the people that are going to use that. So we include a RGB LED in order to show the status and the internal state of the machine. If it's working in the correct way, which state is working at the moment. And we use also push buttons in order to make the physical interaction easy.
Okay, so when talking about the Windows app, so to make the system easy for use of therapists, we developed a window application using C# that interfaces with the Arduino Nano and display the real-time data, providing a user-friendly interface. So what you will find in the program first is a login screen that ensures that only authorized therapists can access the application. Then there is a patient data form that allows the therapist to input and manage the information in many important variables like height, weight, and also the age. The connection interface, which provides usage instruction for connecting with the device, and the game itself that requires the patient to perform tasks that are monitored, and finally generates a PDF with the report, with the medical report and all the results and data. So what is the game itself? The goal is obtaining the orientation readings to develop an interactive rehabilitation game that encourages the hip mobility in children. So to score more points, the patient should bend in a combination of a forward and sideways bending to be able to make the shark reach the fish to eat it. And then another fish appears in a new random position in the screen. So about the sensor calibration. For sensor calibration, first we collected the data, synchronizing the IMU and the computer vision system at each of the timestamp. So in order to model and identify the biases, the scale errors, and apply all the regulations for fitting. Finally, we apply a fixed offline adjustment in order to get our measurements. The comparison between the BMI 270 and the computer vision. So in precision, of course, the computer vision has a type A uncertainty of 0.0014 degrees. And versatility, obviously, is better the device. The sensor could be wear anywhere in the area covered by the Bluetooth connection, while the computer vision is subject to be close and facing the camera all the time. And the effect of noise, the robustness, of course, the noise and drifts are corrected by our filter in the case of the device, while the computer vision is always affected by the optimal lighting conditions and other environment facts. So those are the benefits for the therapist. The real-time monitoring that provides immediate feedback and adjustment during the sessions. Comprehensive data, which can be analyzed and assess patient equilibrium and progress over the time. Interactive engaging that include game, more engaged for patients and improves compliance and outcomes. And finally, the report generation, which facilitates better communication with patients and other healthcare providers. So this is the login screen, the patient information where you can upload a photograph, the brief medical history, and all the data from the patient. This is how the interface for connecting looks like, providing instructions for the batteries and the connection with Bluetooth, and also the interface with the game. Finally, this is the report where you can see all the data, the score obtained, the position of the center of mass of the body, the position with the set point, speed and acceleration. So, for future work, first of all, we would like to introduce in future versions some sensor integration like load cells and haptic sensors for capture finer physical interactions, maybe integrate with clinical systems, enhance our processing algorithms, and more validation and calibration, scalability and modularity, and for robustness, some standards like IP67. So all the files can be found at hackaday.io, and there are the 3D printing files, the PCB printing, also the code for the interface and Arduino. So all of this is available at this web page. So sadly, we couldn't bring the product here from Italy, but we would like to show you a prototype testing video where you can see how the device works. It's very brief.
Hi, I'm Sharky, and welcome to the connection assistant of your new device for balance testing. Step 1. Make sure that all the 4 AAA batteries are correctly located in the device. Then, hold the button during 8 seconds until the LED starts blinking in red. Step 2. Make sure that the Bluetooth capability of your PC is on. Then, use the button Start Scanning until you see the Motion Monitor device in the list. Once selected, press the button Connect to start with the game. Great. Your device is now connected. Now, it's time to start with the game. When you're ready, press the button Start, and start moving when the countdown finishes. Remember that you can see the remaining time in your score in the right top of this window. Great. Thank you for your help. Now, you can generate your medical report with the button next to the aquarium. It will be saved in the desktop as patientreport.pdf. Goodbye. Have a good one.
All right. So this is a little overview of the project. If there is any question, we are happy to answer. And otherwise, thank you so much for everything, for your attention. We also want to thank Magenta and Giovanni for the opportunity to be here. And keep on enjoying the Supercon 2024.